Hello and welcome to Lecture 11 of Introduction to Computational Literary Analysis. So today we're going to be talking about WordNet, and we're going to play around with relations between words. All right, here we go. So it's called WordNet, and it's this thing that was developed at Princeton a long time ago, a couple of decades ago or more, and it basically is, you can think of it like a dictionary, but it's a dictionary that contains relations between words, so it's a network of words, and like any network, like any graph, it has nodes and it has edges, and the nodes are what are known as senses, and the edges are relations. So a simple example here from Wikipedia is that you have a word like color, and this has hyponyms like purple, red, blue, and green. These are kind of instances of color, you can think. And the other relation going in the opposite direction is that purple's hypernym is color, red's hypernym is color. So yeah, if we want to get something's category, we want to find its hypernym. If we want to get instances of something, we would find hyponyms. And this also exists for lots of other categories of relations. So, in addition to hypernyms and co-hyponyms and hypernyms, we also have meronyms, which are part of something. And there are different types of meronymy too. So we have part meronyms and we have substance meronyms. And also we have holonyms, which are kind of the opposite of that, in the opposite direction. Okay, yeah, so this is another way of thinking about it. So like we can walk up the hypernym tree, as we say, and we can go from burgundy, to dark red, because burgundy is kind of like a shade of dark red, which is a category of redness, which is a category of a chromatic color, which is a category of a color and a visual property and a property, and all the way up until entity, which is just kind of like a really abstract thingness category, right? And we can do the same thing with meronymy or holonymy if we are interested in navigating the tree of what is a part of what else, right? Yeah, so an example that Princeton themselves provide is that a miracle, for example, is a category, is a hyponym of event, which is its hypernym, right? An occurrence or a happening is an event, right? Damage is part of a change, which is part of an occurrence, which is part of an event. So you can see not everything has a top level category of event. Words exist in this network, and to get information about what something is part of, we often have to navigate this tree, right? So if we encounter the word variation, if we encounter the word miracles, sometimes we have to navigate this tree to go up 1, 2, or 3 steps to find something that's semantically useful for categorizing words. Here's another example that I found. There are lots of varieties of terriers, which is a kind of dog, like a border terrier or an Australian terrier. And these are all types of dogs, which are types of animals. So we could play around with WordNet if we wanted to at wordnetweb.princeton.edu, where it allows us to search for something. So here I've searched for the word tree. And the first thing it does is it gives us choices here between these sen sets. So a sen set is a synonym set or a sense, and we can expand one of these synonym sets. So this is the sense that we're interested in. This is at least the one that I meant when I wrote tree in the search engine. And it says a tall perennial woody plant having a main trunk and branches. So that's the one that we want. We don't want this one, which is a tree diagram, like a genealogical tree. And we certainly don't want Sir Herbert Beerbohm Tree, who is an English actor. Although, we might if we were interested in these things. But the one that I want is just this category of tree. So here I'm given all of these different lexical relations that I can navigate. So what is a tree? What is its category? So let me find its direct hypernym. It says it's belongs to the hypernym of a woody plant or a ligneous plant. Okay, what are some of its hyponyms? What if we walk down that tree? Tree of trees. Okay, yellowwood, lancewood, guinea pepper, anise tree, winter's bark, zebra wood, acacia. So we have lots and lots of these instances of trees. And I know you're going to ask, is Caraca tree in here? But it's not. And that's because WordNet is not super complete. It's not, it's not like the OED or something. It was put together by a lot of volunteers, and there are a lot of things in it, but it's not going to have every word, unfortunately. So in other words, it only gets us so far. So we can collapse this. We can look at part meronyms if we want. These are elements of a tree. We could look at member holonyms if we want. It's a member of forest or woods. We can look at substance meronyms. And, we could also get holonyms by, walking up that tree. Yeah, so here are the holonyms. It's, it's a meronym of forest, wood, and woods. So there are actually even more lexical relations than this that we won't really get into. And, we also have tree as a verb, to tree something or to shoe tree something. It's kind of a little rare. All right, so let's play around with this in Python. So first, I'm going to open up a new notebook, and I'm going to call this 11 WordNet. And I'm going to import WordNet from the NLTK. So I think it's in NLTK WordNet. And NLTK WordNet provides, let's see, a few different things. It provides this WordNet instance. What does that provide? Let's see. Why don't we inspect this? WordNet corpus reader used to access WordNet or its variants. Yeah, that's right. I think I have to import this slightly differently, actually. So I'm gonna say, I think this is in the corpus module. So from NLTK corpus, import WordNet, and I'm gonna call it WN, just like I call pandas PD. So let's see what WN has. So yeah, this is the corpus reader. Let's see what we can do with it. Great, so this is the one that we want. Excuse me. Yeah, so that's the one we want, send sets. We want to be able to look up send sets for something. So why don't we look up synsets for terrier. So there's only one here. So that's kind of handy. This always returns a list. So yeah, it's important to keep that in mind. If we grab the first one from this list, what is that going to tell us? Okay, that's that first item, terrier. So yeah, why don't I call this terrier for now and see what it is that I can do with this. So if I look down here, it tells me that this is a synset object, and that these are some of the things that I can do with it. I can get its name, I can get its part of speech, I can get its lemmas, its definition, some examples, lots of other things I can do with it. So those are attributes, and yeah, I can show you some of the attributes first. So the name is just pretty pragmatic. Yeah, what about synsets? What is that going to be able to give us? Wait, no, it's lemmas. So terrier only has one lemma, but often a sense will have more than just the one lemma. Yeah, so what are other attributes? What about lemma names? Okay, so lemma names, yeah, gives us just the plain text string of all of the different ways that we might see terrier. In this case, it's just the one. Yeah, let's check out some of those methods. So what are some of the methods that we can use on this? We can get hypernyms, hyponyms, member holonyms, all kinds of other things. Also Cs and similar tos. So yeah, why don't we try this? Because we know that hypernyms is going to somewhere probably include dog. So a terrier is a hunting dog. Okay, I wouldn't have really guessed that. Yeah, if we grab that first synset there, that's hunting dog. What if we do that one more time? So yeah, that's a dog, and if I grab that first one, yeah, so that's the hypernym dog. And if I wanted to, yeah, maybe I could assign that to a variable called dog. And now, what if I looked at the hyponyms for dog? So these are all kinds of different types of dogs, and I have a feeling that since terrier is actually in this hunting dog category, that we'd be able to find even more dogs by getting the hyponyms of those hyponyms. So how do we do that? There's a neat method, I believe, called something like tree. So yeah, why don't we see what that tree looks like. It requires a relation, so why don't we give it the relation hypernym. All right, yeah, so let's see how we give it that relation. So yeah, it looks like to give it that relation, we have to sort of pass it a function. And that function would get that relation. So like, if I write a function that says get hypernym for a word, and if I just have that function return that word's hypernyms, actually we want hyponyms in this case. Yeah, so I'm going to call this get hyponym. I'm going to put this up here too. Actually, maybe I can drag this down here. We're almost there. Right. Hypornyms. I totally spelled that wrong. Okay, great. Yeah, so now we have a tree with lots and lots of dogs. Damn, there are a lot of dogs. Yeah, so many dogs. So why don't we call this something like dog tree? Yeah, you can see what the data structure is like here. It's a list of lists. And I can show you how we can navigate this. So the first one is just dog. Second one is Basenji. I don't think I've ever heard of that one. This one is a list of lists with corgi, and it has these two variants. Pariah dog. I wonder what that one is like. So, in other words, for each category, it's a raw item in that list. And if it contains a list, then that's sort of like a subcategory. So let's say, for example, we just wanted to create a list of all of these dogs. Well, we know that if we encounter a senset, we could just get, so this is a senset, for example, we could just get the lemma names from that. And it tells us dog, domestic dog, canis familiaris. Can we specify, can we say like language equals ENG? It still thinks that this is English, I guess. I guess maybe it's a bit of a stretch. But yeah, what if we were to get the lemma names for everything in this tree? So we can walk the tree by writing a function from that tree. So what we're going to do is just go through each item in that tree. And if the node is a senset, right? I think it's WordNet.senset. Let's just make sure that that thing exists. Yeah, so what is this type? All right, so that tells us the type is, it's buried in here. Let's try that. Okay, well, we know that this is the type that we want. Let's see if this is true. All right, so, if I want, I could even write this as a function. I could say is senset. And it takes some node and it returns whether the type of that node is an NLTK corpus.reader.wordnet.senset type. So yeah, we could try it. Is senset dog tree 0. Okay, great. So now we have a little function that can do that for us. I can get rid of this now. So now I can just write is senset node and in fact, yeah, I can make a blank list of lemmas. In that case, we're going to append something to that, but why don't we get the lemmas first from that node? It's lemma names. Yeah, but I'm going to have to call this something different. But since it will give us more than one, why don't we flatten this? We could say, for lem in node lemmas. Yeah, maybe I could call this all lemmas, just to make this a little bit easier. Great. So that's if it's a senset. Otherwise, it's going to be a list. And if it's a list, then why don't we just run this very same function, get lemmas, on that list. Because then it's just another tree. So what this is actually is this is what's known as a recursive function. So it's a function that calls itself. These are kind of hard to wrap your head around. At least they are for me. And yeah, so I wouldn't be surprised if I don't get this right on my first go. I'm going to just put that up there. Yeah, let me try get lemmas on this dog tree. I'm going to put this up here. Now I'm hesitating a little bit because I know that there's the possibility that because this calls itself, I get into an infinite loop, in which case I'm going to have to stop it, maybe restart the kernel. Nodes is not defined, so typo. Oh, right, I'm not returning anything here, so I have to return all lemmas in the end for this to work. All right, so that almost worked. But we're missing something. Okay, yeah, so for one, I think I'm not keeping track of what I'm getting out of this subroutine here. So yeah, maybe I should do the same thing. So that I keep track of the output. Okay, yeah, there we go. So now I have a super big list of all of these lemma names. They have underscores instead of spaces, but that's something that we could easily fix if we wanted to. Wire-haired pointing griffin. That's kind of interesting. I wonder what that looks like. Okay, yeah, that's what that is. Wire-haired pointing griffin. Okay, you learn something new every day. All right, so I can call this dog lemmas or something if I wanted to. Yeah, why don't we walk the other way? So we can walk all the way up the tree. You know, so we could get hypernyms if we wanted to. So instead of doing this, let's write a new function here. You know, we'll call it get hypernym for whatever word, and we're going to return hypernyms for that word, and then we can run the tree function and we can call it like dog hypers or something. Yeah, did I call it get hypernym? Yeah. So what are the hypernyms of a dog? It says it's a canine, a carnivore, placental mammal. It's a vertebrate. It's an organism. It's a living thing. It's a whole. It's an object. It's a physical entity, and it's an entity. So this is cool. You can already imagine how this could be useful if you're interested in doing things like, you have a text and you want to quantify all of the things in that text and say, how many mammals are in this text, or how many objects are in this text, or how many, organisms are in this text. Yeah, so why don't we play around with that? Why don't we see if we can do that really quickly? So I'm going to grab, not the moonstone this time, but a new text since we just read the garden party. And I'm going to get that from readings, content, texts, and I think it's just called gardenparty.md. And I'm going to split it on these, on this thing, because I just have a hunch that, that's gonna work. I'm gonna grab some kind of random number here. Okay, yeah, that didn't quite work the way I had hoped. All right, so yeah, let's do this another way. It's to the garden party. Yeah, and I can actually come over here to the course repository, and I can get readings, content, texts, look at the source code for a garden party. This is all at the Bay. It's kind of like a novella. It's really great. You should all read it. Is it truncated? This version might be truncated. All right, yeah, so there's another way that we could do this. We could say, where can we find the weather was ideal? Because we know that's the way it begins. Okay, so let's take a peek at 74314. But let's look a little bit before that, so, and a little bit after this. So 74400 maybe, and 74200. Okay, yeah, that would be why. It looks like this doesn't use that double pounds that double pound sign thing. So yeah, let me get the index of \n, 3 \n's, and 2, and the. Great. And how does it end? Yeah, what's the next one after this? Daughters of the late colonel, right? So great. And now I can slice it. I could say, give me everything from 74254 to 104246. That looks like the garden party. Does it end? Isn't it, darling? Yeah, great. So this is the story of the garden party. We have successfully split this in kind of like a really painstaking way. All right, so we have a short text. We can tokenize that text, first of all. Did I import the NLTK? Yep, so I can NLTK word tokenize this, and I can call it garden tokens or something, let's say. Let's just take a look at it. So, yeah, I can make a subset of this called garden alpha tokens, where I could say, only give me each token if that token is alpha, is alphabetic. And this effectively gets rid of the punctuation. Yeah, and why don't I also lowercase it? I should have actually done that up here. Yeah, I should actually do it here instead, right before I tokenize it. Great. And yeah, while we're at it, we can limitize this as well. So yeah, what is our limitizer? It's the WordNet limitizer. I can assign that to something called limitizer. And then I could say it'll probably be something like limitizer.limitize. Yep. That happened way too fast. I feel like that didn't really do anything. Oh, it changed was to wa? That's a mistake. Yeah, it changed hundreds to 100. So it's doing okay. You know, maybe I want to use stems instead. On the other hand, the nice thing about the WordNet limitizer is that it uses WordNet itself. All right, so I should come back here for a second and say that if we look at, if we look at our dog synset, we could get lots and lots of things from it. But one of the things that we can get that's kind of nice is we could figure out what level we're at. And I just have to find, let's take a look at this max depth thing. Okay, so it says this is the length of the longest hypernym path from this synset to the root. So this is how many steps it would take to get up to the root, to something like entity. And this says the length of the shortest hypernym path from this synset to the root. And this is the longest hypernym path from this synset to the root. Okay, so I think we want the shortest in this case. This kind of tells us the level that we're on. So this says the min depth, it says, okay, we're kind of like at level 8 right now. And if we go up to hypernym after hypernym, it would take us 8 steps to get to the root, so however, there is more than one hypernym, if we were to keep doing this, carnivore, this is a dry principle thing, we wouldn't want to do this over and over and over. But if we did this 8 times, that's 1, 2, 3, 4, 5, 6, 7, 8. I think, one more. We're about getting closer to the root. So this obviously isn't, this path is obviously not the minimum possible path that we could take to get to that root, which would be something like entity. But you sort of get the idea. And so we could use this min depth as a way of like determining where we are in this hierarchy and stopping if we're at something meaningful. So why don't we do this by only looking at the garden party's lemmas to start with. And then I want to introduce something new here, and that's part of speech analysis. So you may remember this from like 7th grade grammar or something, but you have nouns, which are kind of like people, places, and things. You have adjectives, which are descriptors. Which are things like blue, happy, miserable, huge, all kinds of things like that. And you have verbs, which are actions, which are things like run, jump, write. And you have this problem of, which is a difficult problem of part of speech parsing, also known as like part of speech disambiguation. Because let's say you have, let's say you have a sentence and the sentence contains an ambiguous word like bank or bear, so like he deposited money at the bank you know, here bank is clearly a noun, you know, because this is a place. You know, but you can bank on it. In that case, bank is a verb, you know. Bear is the same thing, like he couldn't bear it. Means that in this case, you know, bear is being used as a verb, like he couldn't endure it, you know. He saw a terrifying bear. In this case, bear is a noun. Okay, so we want to do this with all of the lemmas that we have here in garden lemmas. You know, so we could say there's an NLTK parser yeah, and it's called POS tag. And so POS tag takes tokens. It takes optionally tag set or language. And it basically just tries to infer the parts of speech from things. You know, one of the ways that it tries to infer this, though, is it tries to infer what part of speech is what, you know, by already knowing what the sentences are. And so it really kind of helps if you have punctuation in there to begin with. You know, so why don't we come up here and actually, let's not do this thing where we only get the alphabetic ones, because sometimes we want to keep that. So I'm going to redo those lemmas. Yeah, now let's take a look at those garden lemmas. Just make sure they're the ones that we want. Okay, so now we have periods in it, and this will be easier on the part of speech analysis. So we can say NLTK POS tag on garden lemmas, and we can call this garden parts of speech. Yeah, and let's look at that. Okay, so, and after all, the weather was ideal. So these tags are Penn Tree Bank tags. So, you know, I can just Google that, Penn Tree Bank tags list, and just look at the first thing that comes up. So it will tell you here that, you know, these are codes for parts of speech. So CC is a coordinating conjunction, like and. You know, we have determiners like the. There are adjectives, which are JJ. You know, and you have different forms of adjectives too. You have modal verbs, you have plural nouns, predeterminers, possessives, all kinds of stuff. So, and after all, the weather was ideal is this is a coordinating conjunction. This is a preposition. I forget what PDT is. What is that? Predeterminer. Yeah, it's not really a predeterminer in this case. You know, this is a determiner because it's not all the weather. Because after all is kind of like a set phrase. Weather is a noun. This is a mistake because the lematizer is messing up. So actually, why don't we not lematize it right now? So let's just work with the tokens maybe instead of lemmas. Yeah, so this correctly does it. So this is a past tense verb, and this is an adjective. So great. Yeah, we have the whole thing, and it's all part of speech tagged. Yeah, so I should say by way of warning that the NLTK POS tagger is a pretty slow process. And furthermore, it's not super accurate. So the one in other libraries these days is a little bit more accurate, but this one kind of does the job for right now. Next week, or I think the week after, we're going to be learning how to use Spacy, which has probably the most accurate part of speech parser available. But for right now, this will work. So what we have here, you'll recognize this data structure as a list containing tuples. And so each tuple has, it's a two-tuple, so it contains two parts, the first and the second. The first is the word, and the second is the part of speech. So what if we wanted to create a list of just all the nouns, just to extract all of the nouns? So we could say, get the word for each word in this garden POS list, except for each item is actually we're going to expand it to the word and the part of speech. If that part of speech is in, which is the code for noun. So now we have a list of all of the nouns. So it says garden, party, weather, day, windless. This is not really a noun, so you can see it's not perfect. Great. And if we wanted to make sure that this was a unique list, we could get the set. So yeah, there are some artifacts here. So this is an error. So this is something where we might want to replace all the backslashes with something. We could do that here if we wanted. We could say token for token in garden tokens if that token actually, yeah, we could just say token replace that hyphen if that token starts with the hyphen. We can replace that with nothing. That would we can rewrite garden tokens if we want. Uh-oh. This is probably not working correctly. Yeah, it's not getting us anything because it's probably not a hyphen. It's probably a dash of some sort. It's probably something like that. These are kind of hard to type. Actually, so let's just skip this. Let's redo the garden tokens up here. Yeah, now let's just ignore that error. Okay, so we have lots of stuff that we could potentially categorize in this if we wanted to. We could call this garden nouns. And, we could say what we want to do is, and I can annotate this just as a way of thinking it through. I could say we could walk up the hypernyms tree for each noun until the min depth of that noun is, I'm just going to pick a number like 3. That means that we're all going to be like at the same level, roughly the same level of the hierarchy. Then categorize each noun according to that their hypernyms at that level. Okay, so yeah, how are we going to do this? Well, for each noun, we want to, I'll make this into a function to make this more repeatable. I'm going to call it categorize, even though it's not really categorizing it. Get hypernym level 3, maybe I could call it. So for some word, I'm going to first try to get the synset, yeah, what was that again? wn.synsets. And yeah, I'm just going to say, why don't we get the first item in the list? But what if it doesn't have an item? So maybe I have to write some kind of if statement where I say, if the length of that synset, because this is going to return a list actually, so we could say if it's greater than 0, then our synset, we're just going to say, just give us the first one. And otherwise, yeah, we're just not going to return anything. We're going to return none. Or maybe we just want to return an empty string or something. So now that we have the synset, we can get all of its hypernyms. So I can write a while loop to do this. I can say, keep getting the hypernyms. Or I could walk up the tree. Yeah, I could write a while loop. So, maybe I should talk about this for a second. Surprise. So some of you already know how to use a while loop from other programming languages, but if you don't, it's a pretty simple thing. I could, it basically is like a for loop, but instead of going through each item in a list, you just kind of have this condition. So you can say while, some condition is true, you do something. So for example, I could say while I is less than 10, but first I would have to say I equals 0, print that I, but now we have to make sure that we're incrementing that I. Let's see what this does. It prints all of the numbers from 0 to 9. So it goes through the list and it just keeps evaluating this expression. So it says, the first time it goes through, I is 0, and it says, okay, while I is less than 10, well, 0 is less than 10, so yes, continue. So it prints that number, it prints 0, then it adds 1 to I. Now it comes back here and it says, okay, well, 1, is it less than 10? Yes, okay. And it does that, it does that over and over, but at some point, I is going to be 11, and then it's going to say, well, is 11 less than 10? No, it's not, or is 10 less than 10? So it's not going to do anything else, and it's going to stop the while loop. So this is something that could be useful here because we could say while that senset's min depth is less than, no, is greater than 4, our senset is actually our senset's hypernym, the first one. So what happens if we try the word garden? Yeah, well, let's debug this. Are we getting anything out of this? Okay, it's finding garden. Oh, you know what? It's because I'm not returning anything. So after this while loop completes, then we have the senset that we want. So it says a garden is kind of like this type region, which is kind of interesting. So I gotta stop this print statement because that was just for debugging. So garden is kind of like a region. Let's try something else. Oak. It says oak is like a material. Yeah, let's try peach. Peach is a living thing. Plum is a living thing. Okay, so now we can get a list of living things if we wanted to. That would be really neat. Yeah, so sensets for living thing. Can we get that? So now we can go through each of the tokens, in garden nouns. And we could say, is it a living thing or not by comparing it to this living thing. So living thing is just where I've stored this senset, and I can say, is this a living thing? It says whether or not it's true. Yeah, so actually I can write this as a function where I could say, tell me some word and I'll tell you whether or not it's a living thing. So is this a living thing? Plum. Yes. Okay, is this a living thing? Garden. No, because it says that's actually kind of like a place. Is this a living thing? Oak. Oh. That's funny. Yeah, because what was oak again? Oak, it says, is a material. Yeah, what if I say oak tree? Okay, yeah, that's a living thing. You see, WordNet, it likes to use underscores instead of spaces to indicate that something is like one expression. And yeah, again, it's like what's happening with oak is I sort of expected oak to be the tree, but the first item in its sense set is actually oak the material. And that's just because I'm just grabbing the first thing in that list. So yeah, why don't we do this for all of them in garden nouns? So token for token in garden nouns, if that token is a living thing. Let's see what that is. Yeah, so it doesn't like something here. Okay, so I've looked into this and I see what the problem is now, because what it's doing is when WordNet tests equality for two sense sets, it's testing the name attribute, and sometimes it's getting a string instead of a WordNet object, and so it can't compare those things. Maybe if I don't return anything or return none, maybe this will work. No, still not working because it's comparing none to name. So what we need is here, yeah, maybe I can assign this to a variable first. And I can say if that hypernym is not none, and then else I'm going to say it's false because we just couldn't find that hypernym anyway. So here it says list index out of range, which means that it can't find the 0th item here. So yeah, again, we have to go back up there and sort of fix this by checking the length first. So here we're getting the 0th item, but if there are none, then it doesn't like to get the 0th item. So we have to make sure that it has at least one item in it before we tell it to get that first one. All right, so why don't we call that hypernyms? And then we could say if length of hypernyms is greater than 0, and we can replace this with hypernyms. There's probably a more elegant solution for that. Yeah, it's taking a really long time, so maybe it's in some kind of infinite loop of some sort. Yeah, why don't we stop this? And let's just try only first 40 of these. Maybe it needs to be in a list first. Yeah, so it's getting locked in this while loop. Um, and I think that's because of this whole thing. So if it returns a non-zero list, yeah, we just want to stop this whole thing so it is not going on forever, because it's going on forever. I think break is the keyword that we want, because break will tell this while loop to stop. Ah, so egg is the only living thing in our garden nouns. So what about the first 100? Egg, bushes, canna. Okay, let's look at everything. These are all of the living things it thinks are in the garden party. Egg, bushes, canna, butterflies, grass, creature, lavender, horse, dog, sang mice, daisy, hen. So this is an interesting way of, of looking, of kind of like categorizing the words in a text according to what WordNet thinks those categories are, or more technically not categories but hypernyms. So you can imagine that we could do the same thing, of course, not just with living things, but if we were to change this to some other category, we could compare it with that. And we could do something where we could look through not just all of the nouns, but absolutely everything, and just see what types of things there are in something. So WordNet is extremely powerful, and we only just touched the surface of it in this past hour. So in addition to all of this, you can also get definitions. You can do mild types of disambiguation, and much, much more. But that's it for today about WordNet, and I'm looking forward to talking to you about this on Zulip.